Existence and uniqueness theorem टा कौन actually हमें derive करियो. Let f be a continuous function. Let f be a continuous function. Continuous function on the rectangle. On the rectangle R. And this R is defined like this. Modulus of x minus x0 mod is less than equal to A. And modulus of y minus of y0 is less than equal to B. For all AB are positive. For all AB are positive. And second condition, F satisfies the Lipsch conditions. This is first point. Second point, F satisfied Lipsch condition. Lipsch conditions. So on R. Lipsch conditions. What is the Lipsch condition actually? What we need to show that for the case of Lipsch conditions. So Lipsch conditions means f x comma y1 minus f x comma y2 mod less than equal to k into y1 minus y2. Where k is positive. See here, xy1 and xy2 both are real numbers. xy1 and xy2 both are real numbers. Right? If x0, y0 is a point of R, condition if x0, y0 is a point of R, if x0, y0 is a point of R, then there exists a unique solution. There exists a unique solution. Of the initial value problems. Initial value problems. Of the initial value problems. Where y dash is equal to represent the initial condition, y dash is equal to f of xy and some initial condition here given y of x0 is equal to y0. On the interval I, on the interval I, such that x minus x0 mod is less than equal to h, where M is defined here, maximum value of the function, and H is evaluated here, minimum value of A comma B by A. This one is the condition for actually Lip's existence and uniqueness solution. So what is the existence uniqueness solution? Your objective is to, for the case of existence uniqueness solution, existence solution, there is two different things. We already discussed what? Existence solution also discussed, as well as uniqueness solution also discussed. For both the case, what happens? Continuous and bounded. For both cases, continuous and bounded. Continuous and bounded. But what happens about combine the existence and uniqueness theorem? Existence and uniqueness theorem. What happens? Now, for the case of existence and uniqueness theorem, another condition satisfied here, that one is the Lip's conditions. We consider two different points of y. For the Lip's conditions, we consider two different points of y, that is y1 and y2. And that is applied in the case of functions. For fxy, your function is given fxy, right? Your function is given fxy. But you here evaluated the fxy1 result, and another result is fxy2. Two different functional values compute from this. Then just subtracted, then result must be arises. This is also mostly bounded. First is bounded, second is bounded, the difference is also a bounded. So what is the bounded value? Now that value must be satisfied here, k into y1 minus of y2. This statement implies Lip's conditions. When our question is asking you define the Lip's condition, just you define these two terms. fxy be a functions, fxy be a function which is continuous and bounded on the specific region x minus x0 less than equal to a, x0 y minus y0 less than equal to b. And two different points of y we have to consider, and which must be satisfied this condition. Which condition? fxy1 minus of fxy2 mod is less than equal to k into y1 minus of y2. If both conditions is satisfied and this property is satisfied, then that is called as the existence and uniqueness theorem. Achha. So for the case of existence and uniqueness theorem after satisfied, then for the case of existence and uniqueness solution, what is your objective? Your objective is to find the value of h, right? Your objective is to find the value of h. How to find h? That is the minimum value of, that is the minimum value of a comma b by m, not a. In previous actually I described that is a, but that is not a, that is m. Our objective in this existence and uniqueness theorem to evaluate or to compute the minimum value of a comma b by m. And a comma b by m, where m is already defined maximum value of the modulus function. Maximum value of the modulus functions. Where h value is lies on the interval of x only, right? The x minus x0, but our condition is previously satisfied. X minus x0 mod is less than equal to also a. Because we given a rectangle, which given a rectangle, and this value, this h value must be lying in this point, right? This h value must lie in this point, and we need to evaluate the h, where it is applicable and how it is used. ଆମେ ଦେଖିବା ଯେ ତାର application କଣ and କେମିତି use ହଉଛି. Suppose one example you have to consider. One example we choose here. This is existence. Acha. So that the solution of the initial value problem, example 1. So that the solution of yx solution of y of x of the initial value problem of the initial value problem, right? Initial value problem, dy by dx is given, dy by dx is equal to y square plus cos x square, y square plus cos x square. Condition that y of 0 is equal to 0. Exist mod of x is less than equal to 1 by 2. This is our problem. So what you understood for this problem? Dy by dx is given. That is also f of x y you have considered. So what are the given parts we can choose? What is the given part here? What is your given parts? Given. F of x y is given. F of x y is same as the dy by dx and same as the y square plus of cos x square. And x0 is given, initial condition is given 0, and y0 also initial condition given 0. Right? X0 is initial condition given, y0 also initial condition given. What is about that? So our uniqueness solution is described. What uniqueness this solution is described? Can you differentiate this function? Can you do the derivative of this function? Yes. What is the derivative here? Del f by del y. Del f by del y. What is the value del f by del y? It is 2y. 2y. That is differentiable. Del f by del y and f are differentiable, right? Are continuous and differentiable. Continuous and differentiable. Right? The function is continuous and differentiable. Why it is differentiable? Over the region of xy. So what is your objective here? Here is given x minus x0 mod is less than equal to a, and y minus y0 mod is less than equal to b. But what is x0 and y0 given in the problem? 0, 0. So that is mod of x is less than equal to a, and mod of y must be less than equal to b. But what is the given another condition? Mod of x is exist in this case is half. So mod of it here is this case. mod of x, right? Mod of x is less than equal to half, and mod of y is less than equal to b. This is given to you. Then what is your objective? You need to find the value of x. Our objective to compute h, right? And that must be exist. So what is the formula of h? Just you look out, h is equal to what? Minimum of a comma b by m. So your m is must be evaluated here. What is m? Just compute. That is our formula is maximum value of the function x comma y. What is fxy? Maximum value, just you put y square plus cos of x square, right? So we just need the maximum value. What is the y value is represented? X minus x, y minus y0 is less than equal to y minus y0 is less than equal to what? B. So y maximum value is b. Condition here, y mod of y must be less than equal to b. The y must be maximum to b. So you put b, y is equal to b. So that is b square. And what is the maximum value of cos x0? What is the x0? That is 1. Or the maximum value of cos x? That is 1. So that is 1 plus b square plus 1. So m is computed here, that is b square plus 1. X nahi, I mean psi cos x ର maximum value we consider. Cos x ର function ର maximum value. So that is 1 we have to consider. So m is you evaluated. So what is the formula of h you mentioned? X value must be lies, right? Modulus of x. Already I told that is the maximum half. Then minimum must be minus half, right? This is the region of the x. Because in the previous condition I have mentioned here, right? Modulus represent that is positive as well as the negative value. So the region of x is defined minus half to plus half. Then one m is equal to 1 plus b square, right? Then what is your objective? What you want to search here? Now h. What is h? Minimum value of a comma b by m, right? The minimum value of a is defined. What is the value of a? 1 by 2. And b, m 1 plus b square. But you unknown the value of b. If you evaluate the b, then after substituting, you compare and find out the minimum value. Are you understood? Achha, you know the minima and maxima criteria. Here, you choose this function. This is you can choose for fb is equal to, small fb is equal to b by 1 plus b square, right? For the case of minima, you know the minimum property. Maximum value, minimum value, how to evaluate. You have already studied in your class 12. So first you do the first derivative of the function. What is f dash b? Just you apply the derivative here by division formula. Then you got here 1 minus b square by 1 plus b square, right? For evaluating the value of b, this value equal to 0, you convert. For evaluating the value of b, let f dash b equal to 0, then b is equal to plus minus 1. No, whole square, right? But finally, that is v is equal to plus minus 1, or you could choose the positive value of the function. 1. Choose the positive value of the given function, 1. Right? Then what is h? Now, what is h? Minimum of 1 by 2, comma 1 plus that is also 1 by 2. Then both are the same value. So minimum is half, h is half. There exists. So h is half. So the unique solution is defined. So the unique solution is defined. Minus 1 negative ଆମେ ଏଠି consider କରାଯିବ ନାହିଁ. Negative value. Can exist କରିବ ନା ସେ? ଆମର ଯୋଉ quadratic ରେ କଣ କହୁଛୁ ଆମେ? A, B both are positive. So unique solution exists and defined it mod of x is less than equal to h, and that implies mod of x is less than equal to half. Okay? Are you understood or not? Okay, so that is your existence one problem I have discussed today. Tomorrow also I will discuss next so many examples. Okay, we will discuss again next class.